Running smoothly, good. I've just cursed it, I'm sure. So what I'd like to do is actually let you know that you can head over to this URL right here, and you can go to that QR code, and you're going to get 50% off on this week's product pick of the week right now, just during the live stream. So head to one of these places that you see right here in front of you, and you will arrive on, let me show you the page, in fact. Where'd it go? That's it right there. Yeah, that's going to take you to the product pick, and if I click on that and refresh, we'll see that we have a 50% off discount during the live stream only, and we're broadcasting from right inside of there, so you can click on that link and watch the show from inside of here. So I encourage you to head over there and watch the rest of the show from inside of the product page. You get 50% off on the product pick during the live stream only. After the show, we kind of shut that off, so you'll want to click buy. I think you have a little bit of a grace period there, but you want to click buy pretty quick so that you can get in on the savings. Hey, Johnny Bergdahl. Hey, Dave Odessa. Nice to see you all over there in the YouTube chat. All right, so before I go any further, what I really like to do is have Lady Ada tell us a little bit about this week's product pick. So please take it away, Lady Ada.
So this is a 24C32 EEPROM. It's a 32 kilobit EEPROM, which is 4 kilobytes of data in EEPROM format. I like EEPROM because, one, it's I2C, so it's really easy to connect, supported by any microcontroller, microcomputer. 4 kilobytes is not a lot, but it's enough to store your configuration data, a key, a MAC address, calibration, username, display settings, what have you, over I2C. And again, these EEPROMs are so common; they're used by a lot. We actually originally stocked these because we use this part in our Raspberry Pi hats because they are used to configure the device tree overlay. But this is very handy if you ever want to add EEPROM to any of your products. A lot of microcontrollers that are simpler, like the AVRs and PICs, have built-in EEPROM, but a lot of the Cortexes, I'm noticing, don't. But if you still need a little bit of EEPROM data to store your configuration, you just plug this in, and there you go. So it's a standard 24C or 24LC. It's a totally standard way of using EEPROM. You can connect up to 8 on the single bus because you can configure the address using jumpers on the bottom. And we've got an Arduino library and a CircuitPython library coming out shortly that'll let you easily address them. Another nice thing about the EEPROM, you can write 1 byte at a time. You don't have to do page erase or page writes or caching or buffering. Each byte, takes a millisecond to write, but you can write them one at a time.
Yeah, all right, so that's the product pick. What I'm going to do is actually go and grab one out of my Wonder cabinet back there, and then let's talk about it. Hang on one second. There it is. This is our product pick of the week. This is the 24LC32 EEPROM breakout. Now, this is a Stemma QT accessible board. You can also just use breakout pins on there, solder some pins onto there. But I really like using the little Stemma QT / quick cable to plug it in. And if you didn't know, if you're not familiar with this, so EEPROM, it stands for Electronically Erasable Programmable Read-Only Memory. And what does all that mean? That means that this is some memory that you can write information to, and it's not going to go away when you pull the power on it. So it's a little piece of storage that you can use. It's 4 kilobytes of data, which means that you can't get too fancy with it, but as one of my consultants was telling me before the show, okay, it was Todd Bott, the original Atari cartridges were 4K. So you could fit a decent amount of code on there if you really had to. But more likely you'll use it for things like configuration data, for maybe a MAC address or some sort of secrets file with some login information. What I wanted to do is actually show you, first of all, actually let's take a look back at the page there. That's where you can go to get yours, and check it out. These are, just refresh there, these are on deep discount during the show, so you can get one right now for $1.98. It's pretty great, and it'll work with pretty much any of our microcontrollers or any microcontroller out there that supports I2C. And let's take a look also at the Arduino library. So right now we don't have a CircuitPython library yet, but if you head down here into the product description, there's a little link that says we recommend our FRAM EEPROM library. That is it right there, and you can of course access this from within the Arduino IDE, and I'll show you how to do that in a moment. And once you have that installed, then you can go ahead and write information to it. It's not something you'll do all the time, but more likely you'll then read the information off of it. Now you can do, I believe, about 1 million writes on it, so probably you won't run out of space depending on how you're using it. But let's get to a demo, shall we? So let me jump to the, yeah, let's actually, you know what, I'm going to do just the overhead first for a moment. Let me take that off of there. Yeah, that'll work. Okay, so here what you can see, a little demo I've set up. I have a Feather. This is a Feather M0, which does not have EEPROM on it. And I've got a little OLED Featherwing plugged into it. And then I have a little strip of NeoPixels. I have this Stemma QT cable plugged into the Featherwing. And you can see my program there says EEPROM reader. And then I have little columns there for address, a hex, and a value or decimal value. So what I'm going to do is I'll go ahead and plug in one of my EEPROM breakouts. And nothing fancy, I'll just reset the board. And now when it restarts, you'll see it loaded in the first 4 bytes of information on the EEPROM. So it looked at address 0, 1, 2, and 3. And from that, it grabbed these hex values, C, C8, 32, and 4. Or you can see those in decimal as 12, 250, and 4. So what are those? Those are the RGB values of a number of NeoPixels. So I said in this case, give me a green sort of aqua color, and we'll light up the first 4 of those NeoPixels. Now what I can do is go ahead and unplug that, just like a game cartridge, plug in a different one, and again, I'll just go ahead and reset, nothing fancy. And now we've loaded in some different EEPROM values right off of the card or right off of the chip there. And so now we've got these more of a magenta. I'm loading in R, red is 100, green is 0, blue is 50, and I'm saying only light up 2 of those NeoPixels. So this is just a kind of quick, easy demo of a way that you can use EEPROM. That data is non-volatile. It's not going to go away when I unplug this. I've taken power off it. I can go ahead and plug the first one back on there. Reset, and you'll see we go back to our sort of cyan color with 4 NeoPixels. And we can rewrite that with different info if we want. Let's take a look at the code for this. So here you can see I'm doing this in Arduino. And let me go ahead and pull up my Arduino IDE. Where'd you go? There you are. Okay, so what's going on here in this code? First of all, I'm going to import some libraries here, including this EEPROM I2C library. Then I've got setup for it where I'm creating this object and calling it the I2C EEPROM, which we can then talk to. And we're defining which address it's on. So like most of these little Stemma QT boards, we have some jumpers on the back that you can solder to pick a different I2C address. You can have up to 8 of these on one I2C bus because you can configure the address that way. And depending on the microcontroller on, you maybe have multiple buses of I2C because you have a lot of these on there. Next thing I'm doing is setting up my display, setting up my NeoPixels, doing a setup here of the EEPROM. So you can see here we're checking to see if it's actually connected on that address, and if it is, we go ahead and start. So here is, you can see I've commented out this code right now because I don't want to rewrite to it every time that I load this code on, but this is where I can write different info on there. So let's say we're going to rewrite this to be pretty much pure blue. So I'm going to set these to 0, 0, 255, and how about we'll light up 6 of them. So when we send this to the board, it will now rewrite those first 4 bytes on the EEPROM, and then later when we reload the program and we're just in the read mode, it's going to pull that data off and use that for our NeoPixels. So I'll go ahead and uncomment this for when we try to load that on in a moment. But before I do that, let's look at the rest of the code. So you can use this to dump the entire contents of the EEPROM. That takes a little while, especially if we're kind of put it on this screen. So I'm just reading the first 4 of them. And then I am displaying those on the screen. So you can see, rather than serial print, I'm using display print. And then I've set up a little bit of text formatting there to display those values that we read for each of those 4 entries. Here you can see I'm creating an integer. This could also be a uint 8. But I'm reading in the 0, 1, 2, and 3 addresses. And then I'm setting the pixel colors to be those 3, the 0, 1, and 2 address. And the number of pixels right here is this one that I called n, which later I'm iterating through with I, just to confuse myself. And that is all that it does. So let's go ahead and we'll see if we can, it's not always a given, but we'll see if we can upload to the board. So hopefully I've got everything set up right and it'll accept new code. So I've just compiled the code and it didn't break. That's good. So now I'll hit upload and that's going to recompile it and push that up to the board. And now it has rewritten those first 4 bytes with this blue color, pure blue color. And or it's in the process of writing that right now to the Arduino and to the EEPROM. So we'll hang out a minute. Uh-oh, I've run into an error. It was not a guarantee this was going to work because I actually wasn't coding on this board earlier. Let's see. First thing I'm gonna do is actually just bear with me. I'm gonna check that I'm writing to the right board. If we use the USB back for Arduino. So let me that. I saw. That chat, because sometimes the chat's the trouble. Let's see. No, good. Okay. No one's noticing anything terrible with that. So compiling sketch, uploading, crossing fingers. If it doesn't find the port right away, you can double-click the boot button on the board there. Hey, it worked that time. Okay, I was using the wrong USB stack. Okay, so what I'll do now is I'm going to comment out this section so I don't keep rewriting that. Otherwise, we'll never see a change. And now I'll upload this again to the board. Of course, there are other ways you could do this. You could even create a little interface on the display itself with little buttons to write data. There's a lot of ways that you could do that, but right now I've just got sort of a bare bones demo going. Okay, so now you can see on my display, let me go back to a full display of the board.
So this is a...
Whoops, where'd we go? There you are. Okay, let me go to that view. Okay, so you can see here on the board now on my address 0, it's a value of 0, so that's red. 1 is 0, that's green. Address 2 is full on, 255, blue. And then address 3 here says we'll light up 6 NeoPixels. So again, just to kind of test this out, let's go ahead and reset that. When this launches, it'll light up those 6 as blue. If I swap out my other cartridge here and reset that, that's going to read the magenta 2 pixels, and then we'll go back to that blue one. Now, of course, since you can load multiple of these onto a single I2C bus using different addresses, you could read from them with a whole bunch of them plugged in. You could go and read data off of a few of them, swap them around. So you can imagine this is sort of a neat like cartridge idea where you can carry around some important data with you. You could also use this as a way to quickly update, let's say, NeoPixel animations on a cosplay prop. Put it maybe in like a big phaser gun with sound effects and things and drop in a different EEPROM in order to upgrade the device. So there are a lot of possibilities with a simple little inexpensive piece of EEPROM RAM or ROM like this, and I find it a whole lot of fun to work with. So let's see. if there are any questions, let me know over in the chat. Let's see. Can you tell how much memory is free or used? Yeah, Dave Odessa, you can. I think if I jump back over to Arduino for a second here, let me open up our example code. So I took when you load the library, you'll get this example code here. 1 second while I load that up. And this is in the FRAM. Okay. So let me swap over to this other window for you. 1 second. You know what I'm going to do? I'm just going to copy that text and put it into Atom so that you can see. That'll make it easier, actually. Hold on 1 second. Libraries. Oops. 1 moment. So close. Here we go. All right, yeah, so you can see this is the example code that you'll get with the library when you load that into the library manager in Arduino. And in here, it actually checks the amount of RAM that you've used. It will let you know that. It will write out the whole. This is better for a serial console so that you don't flood a little display like this. It'll write out the whole content of it. Yeah, I think that's about it. So this is a nice one to go and check the full contents. And then, of course, you could write parsers to do other things with it if you needed to. Let's see. Other questions? Seagrover asks, any projection for when a CircuitPython library may become available? I do not know. That's a good question for probably the CircuitPython channel here in Discord. Lady Ada mentioned it, but I don't remember if she said when it's coming. Unless you want to get working on that yourself, that would be great. We wouldn't mind at all. We would appreciate it. Oh, someone said we had a max headroom effect going on before, huh? Oh, that's funny. It was probably when I was loading things and it confused the software. All right, yeah, so that is the very cool little EEPROM breakout there. A lot of fun to work with. Very simple and easy and pretty quick. As you can see, you can just write to individual bytes, which is great. You don't have to gang up a big buffer and then write that. So it allows you to go in there and just pinpoint the addresses in memory where you want to write some information to. So it's really easy to work with, which I appreciate. And I think that's going to do it. So let's see if you have other questions over in the chat on YouTube or in the Discord. Let me know. I'll take a look at those and I'll hang out a little bit after the show. But don't forget, if you head over to the products page here, this is 50% off, so it's $1.98 right now. We have 93 in stock, and there are a maximum of 10 per customer. So you do the math. If you want to grab a bunch of them, grab them quick because they might be gone. And of course, we'll always make more, but the discounted price is good just during the show. Also, you can see here, if you take a look at the pictures, these nice product photos that we have there. There's the nice little EEPROM chip, and there are the address jumpers on the back that you can just get a solder blob across those or a little wire and pick a different address for these. And whoa, that's going to do it. All right, so why don't we wrap this up? I'm going to take this one right here and say that's the product pick of the week. It is the 24 LC32 EEPROM breakout on I2C Stemma QT form factor. And I'm going to go ahead and put that on my new product board of awesomeness. The names change a lot. And that'll do it for today. So thank you all so much. And for Adafruit Industries, I'm John Park. This has been JP's product pick of the week, and I will see you next time. Bye-bye, everyone.